Hi, this is Jack from tritiumsoft.com talking to you today a little bit about BulletCalc3. Let's begin. As you can hear in BulletCalc3, we have a lot of real machine gun and other firearm sounds just as a little extra bonus to the program. They don't change the way the program functions, but they add a little bit of character. As you can see here, it's very easy to calculate large amounts of ballistic data with BulletCalc3. Using the calculate button, we automatically calculate 100, 200, 300, 400, 500, and 1,000-yard ranges every time you press the calculate button. In addition to that, we also calculate whatever specific target distance you choose to specify in the top. There are defaults, but the beauty of BulletCalc3 is that you can change nearly every element of this to customize your calculation for your own situation. So if we go down here, what we can see is we have the caliber, we have the grain of the bullet, which is the mass, the muzzle velocity in both feet per second and meters per second, the muzzle energy, that's the energy the bullet leaves the gun at. So we have it both in foot-pounds and joules. Those are equivalent. They just have a different, they're just different units, physical units. And we have the time to target. How long? This is the minimum time that the bullet can take to get to the target. Distance to target. So this just gives us the same measurement in both yards and meters, so that sometimes you want to use yards, sometimes meters. In the United States, we usually use yards, but a lot of firearms that are foreign, a lot of measurements come specifying meters. So the beauty of BulletCalc3 is that we don't just give you choices, we give you both. So in case that there might be one or the other, we try to give you as much flexibility as possible, which means that we go between metric and standard units. We allow you to mix them, which is a fantastic feature of this program. What we also have here is the average speed. So as the bullet leaves the barrel, it's slowing down every yard that it's moving. It's getting slower and slower and slower. It might be just a little bit. It could be a lot. It all depends on the situation, the size of the projectile, and the speed it's traveling at. But there is an average speed, the speed that it took to go from the barrel to the target. We have the bullet drop distance. So with gravity, which everything on Earth experiences a gravity towards the center of the Earth. What this bullet drop distance tells you is over the distance to the target, how far was that drop? So if you had, instead of firing the gun down the range, if you had just taken a bullet or a projectile and just dropped it towards the ground, how far would it fall in the time that it took for that bullet to go to the target? That's what bullet drop distance is. Bullet drop speed at the target tells you how fast is that bullet moving towards the ground at the time that it hits the target. So that's what it means, is that that bullet, everything that is dropped towards the earth experiences change in speed, experiences a constant acceleration, which means that if given a certain amount of time, unless there's some huge amount of aerodynamic drag, such as in a parachute, it's going to keep speeding up until it actually strikes the earth. And in this case, what we're saying is that if it did fall, what would its speed be when it, at the time that the bullet hit the target? So in the amount of time that we gave the bullet to hit the target, how fast would a bullet that was just dropped towards the ground, how fast would it be falling when it hits the ground? Because the big implication with that is the faster that it's traveling, very small differences make up for very large amounts of distance. So I'll put it this way, is that if an object only falls for a fraction of a second, the difference between half a second and 1 second is very small. But if an object's been falling for 3 or 4 seconds, the amount of distance is huge. And so just think about this. If you fell off, or let's say you jumped off of a bridge, the first second you moved a lot fewer feet towards the ground than in that last second. In the last second, you moved an enormous amount of distance, because you're traveling at high speed, and that's what kills people, is because you're going faster and faster and faster. If you just fell at a constant rate, it'd be like falling with the parachute. You know, the parachute hits a certain number, and then beyond that, unless the parachute fails, you're going to safely hit the ground, or at least you're not going to die. And so if we go down here to the next one, the bullet energy at the target. So we had the muzzle energy, which was the energy the bullet left the muzzle at. And the energy is based off the velocity, which really just means the speed, the miles an hour. So it's the miles an hour and how heavy it is. That's what's going to give you that muzzle energy, right? We have kinetic energy equals 1/2 times mv squared. That's 0.5 times the mass of the object times the velocity squared, in the right units, of course. So we have the same thing when we get to the target. Because the bullet is traveling slower, the amount of energy has decreased. We've lost energy to all that air that the bullet passed through. So just like if you stuck your hand out the window while you're driving down the freeway, and you can feel the force of the air pushing on your hand, it's the same thing with the bullet. The bullet is pushing on that air all the way to the target, and so there's less energy. All that energy had to be paid for, because unlike you in the car, where the car is providing the energy, that bullet was thrown out of the barrel, and there's only so much energy before it's gone. And so the bullet energy at the target is, that speed. You have the same mass, it's going slower, and so that gives you a different bullet energy at the target. And then the last one was we have the bullet speed at the target, and we give you different units: feet per second, meters per second, miles per hour, and also the Mach number. So it's a very nice feature of BulletCalc3. So that's just a quick overview. We'll go over more items in the next video.